Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. My name is Muhammad Daffa student number 220606156. And hari ini saya akan uh, menjelaskan sedikit tentang contoh soal optimisasi dalam numerical methods. And of course, dengan menggunakannya dengan metode Daffa. Oke, kita bisa mulai dari Daffa dulu. Jadi Daffa adalah metode yang propose oleh Pak Dai, dan it consists of intention, initial thinking, idealization, and instruction set. Jadi dari semuanya kita harus mulai dari intention dulu. So our intentions on working on this problems is of course to solve the numerical methods problem, and also to get closer to God and to understand God more by doing so. And how do we get to that? It's when we solve a problem and when we understand something more, we'll know that it'll ultimately lead us closer to God, because as everything else in this world is made by God, and so are we. We will appreciate more what God has made, and we will appreciate God more by understanding more and learning more, and solving these problems. Okay, we'll get straight into the problems. So a rectangle block has a square base of side x centimeters and a height of y centimeters and a volume of 80 centimeters cubed. The base and the top are to be covered with the paint costing 3,000 rupiah per centimeter squared, and the sides with paint costing 4,000 rupiah per centimeter squared. And here we are required to find the values of x and y for minimum cost. So we're uh, required to find the optimal values for x and y so that the cost will be minimum. And we can get straight into initial thinking. So the problem says that it has a square base side x and height of y. So we can draw that, and this will be the square rectangle block right here. And it has a x square base and y height. So this would be all y, and this would be all x's right here. And the volume is 80 centimeter cubed. So we can summarize that as the formula for the volume of rectangular block is x times x times y. So we can say that it's x squared times y. So it's x squared times y equals 80. And we can get that y is equal 80 divided by x squared. And we'll need that because we'll be using that for the other formulas and the other equations that we'll be receiving. So x in this has 8 in total. As you can see here, x, 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 and this also has 4 up at the top. And y has 4, because it is only has 4. And we're asked to find the minimal cost. So we're asked to optimize the values of x and y. Now we can get straight to idealization. From here on, we can get the formula for the cost for the rectangular block, and we can turn this into a mathematical form as said here. So since the x is cost 3,000 per centimeter squared, we can write that as 3,000 times 2x, because there's 4 right here, x right here. No, I mean there's two sides of rectangle in here. So the reason why it's 2x squared is x squared. X squared is the formula for a rectangle. So we have two rectangles right here, up and down. And here we have a square. So we can write that as 4,000 times 4xy, because the formula for rectangle is x times y. And we'll use a plus because, of course, is the sum of those two. and we can calculate that and get that the simplified form would be 6,000 x squared plus 1,280,000 divided by x. As we can see here, the y we replace from the y that we get from the initial thinking, that is 80 divided by x squared, and the simplified form would be this. Okay, now that we have everything, it's been simplified and it's been all idealized, we can move on to the instruction set. And here, then this part is where uh, we can optimize this equation with differentiation, and we can obtain the minimum value of x and y to optimize the cost of painting this rectangular block. So we can differentiate this equation, which is dc per dx is equals 6,000 x. We can move that, and we'll get 12,000 x minus, since this is we can change this from 1,280,000 per x is basically 1,280,000 x minus 1. So if we differentiate that, we'll get this will be, sorry, x minus 2. And we can just change that, since x minus 2, 6x to the power of minus 2 is basically, you know, we'll get per x squared. So it'll be 1,280,000 per x squared. And that basically all sums up to 0. And we can uh, simplify this by multiplying all of them with x squared. And here we'll get 12,000 x cubed divided, no, uh, dikurang 1.280.000, and we can get and simplify it, and we'll get x equals 2.19669, and that's the minimal value of x. And we can get y by uh, inputting the value of x into the y that we already got here. Y equals 80 per x squared, and we'll get that y equals 16.57878, and that's the minimum value of x and y for this particular problem. And we can move on to the other problem, and this is a problem that I made myself, and I think is sort of like a simple problem, but not really doesn't really apply to real life situations, but it could be something for thinking, and it could, you know, uh, be an easy example of optimization, numerical methods, especially in differentiation. So, as of course, again, our intentions are still the same intention, and we can move on into the problem itself. So let's say there's a password requirement if you're signing up for a website, and a certain site requires numbers inside of the password, and this particular site is very tricky about the password requirement, and the numbers itself has to be a product. It has to have a multiplied product of 400, and whose sum is minimum. So it asks for the most minimum sum. Very tricky requirement for a website to have for a sign up, but we'll roll around with it. And so, how do we find those numbers? So we'll get to the initial thinking. Okay, so the password, we'll type it as P, and the numbers as is, we must equal it to 400. So P x times y must equal to 400. Okay, we can get straight to the initial thinking. So uh, again, for the password, the P, we'll say that is P, is x times y, since we're required to find the sum minimum. So p must equal to 400. So the product of x and y should be 400, and the s, we'll have the sum as s, must be a minimum. So the minimum of those combinations. So sum is of course the sum of x and y. And we can move on to the idealization. So p equals x times y, 400. So p is 400, and we can get y by dividing p in both sides. So we'll get y equals 400 divided by x. And from then on, we can get the x by inputting the value of y in the sum formula. So we'll get that s equals x plus y, and we'll get that x squared equals 400. And from this on, we can easily get the x and y. So the x squared, as we get from here, if we square that both, we'll get that x is plus minus 20, and since it wouldn't be a minus, that wouldn't make sense. So x would be 20, and since we already get x is 20, we can input that to here and get that y is also 20. So the minimum sum is actually 40, and the product of 20 times 20 is of course 400. Uh, so that's the example problems that I have provided for numerical methods. If there's any question or any uh, opinions that you would like to put, please put them in the comments below, and uh, maybe you can even chat me about it. Sebelumnya mohon maaf dan terima kasih. Assalamualaikum warahmatullahi wabarakatuh.